For this exercise, we need to determine the perpendicular distance between a pair of lines. One underlying message for such problems is that the lines are parallel to each other. Otherwise, at some point in space, they will eventually intersect with each other, making the distance zero. The perpendicular distance between a pair of parallel lines refers to the shortest distance between them, which equals the length of the dotted line shown here. Eventually, we need to determine the distance between the two endpoints of this dotted line. We can sketch the two lines in space first. The first one is shown in blue and the second one is in red. To determine a line perpendicular to the pair, we start by choosing a point on either one of them. For convenience, we can pick a point where its x or y coordinate is 0, just to make calculation simpler. For demonstration, let's just make a point A located at 0, 2. Since we already know that the dotted line passes through point A, we can determine its expression if we also know its slope. This is easy because we essentially already know the slope of the parallel pair. For example, if we rearrange the expression of the red one, we'll get that the slope of the red line is minus 2 over 3. This immediately tells us that the slope of the dotted line is 3 over 2, because in 2D coordinates, if two lines are perpendicular to each other, the product of their slopes will be minus 1. And now we can apply the so-called point-slope form to determine the expression of the dotted line. Essentially, the change in y equals the change in x multiplied by the slope. Plugging in the coordinates of point A, we get that the dotted line is y equals 3 over 2 times x plus 2. Now we just need to determine the distance between the two intersecting points. Let's call the other intersecting point, point B. The perpendicular distance will be equal to the distance between A and B. In order to determine the coordinates of point B, all we have to do is to solve the expressions of the dotted line and the red line simultaneously. I believe you can work this out yourself. The result is shown here. Now that we have the coordinates of both A and B, we can find out their distance, which equals 15 over square root of 13, roughly 4.16 units. I recommend practicing this exercise again, using a point different from point A, and see if you would obtain the same result.